Thank you for the introduction, and good evening, everyone. In my talk, I'm going to be talking about Alluxio's unified namespace, which is a feature that enables a lot of the things that you already heard about in presentations by HY and Gene. To get things started, let me tell you a little bit about myself in addition to what you already heard. I'm a PMC member of the recently founded open source project governance for the Alluxio open source project and a maintainer of several of its components. You can see my Twitter handle here as well as my GitHub in case you would like to follow my open source contributions. In this talk, I'm going to start with motivating the unified namespace feature, which is going to build on some of the ideas from HY's talk. I'm going to then talk a little bit more about the details of what unified namespace actually provides you with and how it works, and also cover some use cases, kind of categories of workloads or problems that you might be able to solve very well with the unified namespace feature. And then I'm going to end with a demo. And hopefully the whole presentation will also be very short and sweet because it's already getting late. So this figure might look familiar. It's very similar to the one that HY had in his slides. What it illustrates is that thanks to a lot of the innovation that happens in the hardware space, thanks to companies like Intel, speeding up computation and increasing the speed of storage or the capacity of storage, as well as lowering the price, we're seeing new technologies, both in the space of compute frameworks as well as in the space of storage systems. And it's great because it allows us to build these very sophisticated methods for processing large amounts of data very quickly, generating insights ever so faster. But maybe not by a surprise, it also introduces this interesting challenge of integrating all these new technologies that are coming up, both on the compute side and the storage side. And I refer to this as the M times N problem, which is very hard to solve because if you create a new compute framework and the compute framework would like to work with all the existing storage technologies, well, that might be very hard to do out of the gate. And the do of that is if you create a new storage technology, typically you will end up focusing on some particular compute frameworks as the targets for the workloads that you want to be serving. With Alluxio and its unified namespace, our motivation is to reduce this M times N integration problem to an M plus M integration problem, thus greatly simplifying the integration problem in the big data ecosystem. And the idea is that the compute frameworks really only need to understand how to talk to Alluxio through one of its interfaces, whether it's its native interface or the Hadoop compatible interface or the Fuse interface. And Alluxio, on behalf of the applications, manages the communication with the underlying storage systems. Alluxio already contains support for most of the popular distributed storage systems, like the cloud storage, S3, GCS, Swift, or distributed storage systems like HDFS or GlusterFS. And so the benefits that the unified namespace realizes for you by doing this is, well, the two main ones really are that if your application uses Alluxio's interface, I like to refer to this as it's being future-proofed, meaning if the location of the data that your application wishes to consume ever changes to a different storage system, your application, in the extreme case, might not need to change at all. And in the common case, all you would need to do is to update the URL to reflect the new location of where the data resides. But you don't need to change, and the important part here is that you don't need to change any of the API responsible for both reading and writing the data in your application. And thus, the application can solely focus on the business logic and don't have to worry about integrating with a different type of storage system that now stores its data. And the other benefit is something that HY already touched upon, which is Alluxio, putting Alluxio in the big data ecosystem can enable new workloads, because Alluxio already is integrated with many of the popular compute frameworks as well as many of the popular distributed storage frameworks that might not necessarily be integrated with one another pairwise. So by the virtue of using Alluxio, you might be able to run computations on top of storage that would otherwise be not feasible without Alluxio. So now that I've provided some motivation for Alluxio's unified namespace feature, let me tell you a little bit more about what it actually is and how it looks like in practice. So unified namespace, in my mind, is an abstraction that makes it possible for applications to access different storage systems through the same interface without really worrying what particular storage system the application is talking to. And the way it accomplishes this is through several concepts. One of the concepts is what we refer to as transparent naming. On this picture, you can see two namespaces. By now, hopefully, you're familiar with the fact that Alluxio provides you with a file system namespace. And this file system namespace in some way mirrors the file system namespace of the underlying storage system. In the case of this example, it mirrors the namespace of the underlying HDFS storage system. And operations that application perform over objects in the Alluxio namespace are reflected in the HDFS namespace transparently on the application's behalf. And vice versa, if the application wishes to inspect part of the namespace that doesn't yet exist in Alluxio, however, it exists in HDFS, Alluxio will, as of the latest version, transparently bring that part of the namespace and mirror from HDFS and mirror it into Alluxio. And we will actually see how this works in practice in my demo. And the nice thing about transparent naming is that if you ever, for whatever reason, need to talk directly to the underlying storage system, as opposed to going through Alluxio, you will see the same hierarchy of folders and files as you did in Alluxio, which wasn't always the case. In the earlier versions of Alluxio, it was actually just a flat set of integer identifiers. And the other aspect of the unified namespace, it's really the unified nature of it, which is it doesn't have to be just one underlying storage system that is being mirrored by Alluxio's unified namespace. In this example, what you see in the middle is Alluxio's namespace, and its root is backed by an HDFS namespace. That would be on your right. And you will see that the data directory is actually backed by a different storage system. In the case of this example, by an S3 storage bucket. And this is very similar to how, for example, in a local workstation, you can have many different storage partitions mounted onto your local file system through the VFS interface. If you're familiar with that, your applications can interact with data stored in, whether it's on hard disk or an NFS partition or an SSD. Your application doesn't really need to know where the data is physically stored. Well, it kind of works the same way for Alluxio at a distributed level. Your application doesn't need to know whether it's working with data that's stored in S3 or HDFS or Google Storage Bucket. It just interacts with the storage system or storage systems through the Alluxio namespace, and Alluxio facilitates the communication with the different storage systems on applications' behalf. And similar to the local workstation example, you can add and remove these mappings between underlying storage systems at will. And that can be done through an API for mounting and unmounting storage systems to and from Alluxio's namespace. So after I talked a little bit more about how the unified namespace feature works or what are its components, let's go over some high-level use cases for where Alluxio and Alluxio's unified namespace might be a good fit for your needs. So this is actually a very, very general example that can match a lot of use cases. And it's basically an example where you would like to build a data processing pipeline that either uses multiple compute frameworks or multiple storage systems. And by using Alluxio in the middle, you can really benefit from the aspects of the unified namespace feature that I already talked about. Namely, the different compute frameworks can focus on the business logic and not worry about the individual storage systems that they access data from. And the storage systems might actually be accessed by applications that wouldn't be able to access data from those storage systems if it wasn't for Alluxio, because Alluxio is the mediator of the communication that previously wouldn't be possible. And the other category that I would like to highlight here, where Alluxio's unified namespace feature can be beneficial, is a category that goes back to future-proofing your application. In case where the location of the data that your application consumes is to be changed. And traditionally, this is actually a very challenging thing if you would like to move your data from one storage system to another storage system, especially when the API of the two storage systems are different. This is illustrated on this figure where to go from left to right, the edges between the application and the storage system boxes might actually involve changing application code responsible for reading and writing the data. And that's something that can be very labor intensive and can seriously slow down the process of optimizing your storage backend. However, if your application was future-proven, if you will, and was using Alluxio to communicate with the storage backend, then you can replace the storage system underneath Alluxio, and your application doesn't need to change at all. In the case where you actually mount the new storage system onto the same location where the original storage system was mounted. In case you want to mount it someplace else, you might need to update the URLs in your application. But such a change, it's a much smaller change, and also the likelihood of something breaking in the application is much smaller than if you were to take out the API used for communicating with the old storage system and replace it with an API for communicating with the new storage system. So after covering these two high-level use cases, I would like to show you a quick demo that illustrates how the unified namespace feature works. And for this demo, I'm going to reuse the setup that Calvin used for his demo. In particular, I have an Alluxio instance running on this laptop, meaning both Alluxio master and Alluxio worker are running on this machine. And Alluxio's namespace is being backed by an S3 bucket that was serving the files that Calvin was using in his example when he was running a Spark computation. We can inspect the namespace of Alluxio using the Alluxio command line client. So the interface the command line client provides you is similar with the interface you have to your local file system. And in particular, we'll see here that there's actually 4 different files in that storage bucket, files of different sizes. We didn't quite know how fast the Intel network will be. And you will also see that one of those files is in memory. That's actually the file that was used by the example. And so in the course of Calvin running his test, that particular file was brought from S3, and now its data are being stored by the local Alluxio worker process in a RAM disk on this laptop. What we're going to do next is, through this particular command, we're going to mount a Google storage bucket that we created for the purpose of this test onto Alluxio path /GCS. And before I do so, let me show you the contents of the storage bucket. Well, it's not very visible here. Let's see if I can make that better. Yeah. So this is the storage bucket. There's one simple file, hello.txt. Now we've mounted the storage bucket. And what you will see is, if we ls the file system again, so you will see that now there's a directory called GCS. What if we were to look into that directory? Well, what actually happens in the course of this operation is that Alluxio, on the behalf of the command line client and in general on the behalf of any application, reaches out to the underlying storage system to figure out what is in that directory that we have previously haven't seen, and loads the metadata. So now we actually see that there is a hello.txt file, and we might even be able to inspect its contents in case it's human readable. And finally, what I would like to demonstrate is the ability of an application, and in this case, the command line client, to seamlessly share data between two different types of storage systems. And to do that, what I'm going to do is I'm going to copy this 15 megabyte file from a path that's backed by an S3 bucket. And you should be able to see over here that this file is actually not in memory locally. And we're going to copy it to a path that's being backed by a Google storage bucket. And hopefully it won't take very long. When we tested it out, yeah, okay, it was pretty quick. So, sorry about that. When we now refresh, we see the file in the Google storage bucket. And this just illustrates one of the ways how Alluxio can allow you to seamlessly and transparently share data between different types of storage backends. Okay. And that brings me to the end of my presentation. I would like to thank you very much for attending. I would also like to thank Intel for providing the space and the venue. And yeah, if you have any questions.
Yeah, actually, it's a good time for questions for all the presentation.
Yeah.
So if you have questions, please step to the mic, introduce yourself and where you come from. Yes, go ahead.
Hi, so this is Vishnu from NetApp. I had a question for Gina earlier. So I think in the diagram that was shown, you showed that the Spark cluster has some memory. And so because there's memory consolidation, we may as well have Alluxio as a second layer. And then, let's say Cloud Storage as a third layer, right? Now the key hypothesis that I understand is that memory is really fast. And so the closer you are to compute, the better it is. So my question is, when Alluxio consolidates storage at a lower layer, you're actually introducing a network hop, and so you effectively, that network hop will kill performance, right? And so my first question is, how much of an impact is that versus just keeping that memory in the compute itself, right? And related to that same question is, with 3D Crosspoint that Intel just spoke about, will storage consolidation be important at all? And just your thoughts.
Okay, so thanks a lot for the question. I think to summarize the question, basically, is storage consolidation valuable given that we're getting faster and faster storage media, and introducing Alluxio to the stack introduces an additional hop that you need to kind of get to your data. And I think you do raise a great point. Basically, you're saying well, it's gonna take a ton of time in order to get the data from your remote storage to Alluxio. And I would argue it basically would take pretty much the same amount of time to get the data from your remote storage to your Spark process if you wanted to keep it in memory.
So my question is the hop between the Spark cluster and Alluxio. So
Yeah,
I
exactly.
just keep that memory in the cluster itself,
Mm-hmm.
even if it's a very short LAN network hop,
Yep.
it's still expensive given memory speeds.
Yeah, so exactly. So I was about to get to that point, which is I think the bulk of the performance, you're gonna take the hit over that long network. So like, let's say you take 100 seconds to get the data, and maybe you take an additional 1 second or even less between the Spark process and Alluxio. So in that case, I think I would say the amortized cost is actually fairly low to introduce this additional hop. On the flip side, we do get the benefits that I mentioned in the sense that you will be able to reuse that data, which was read by that Spark process, among any of the other Spark processes that you're aiming to run. And at the same time, that Spark process doesn't end up owning the data, which is pretty important because Spark kind of tasks are designed to be ephemeral. You run it once and then it finishes its task and then it exits. So then you won't be able to keep that memory around in case you want to access it again. Does that give a good motivation?
So let's alternate one mic to another. Go ahead. This mic.
Sure. This is Jean-Christophe from Oracle. You talked about the introduction of users, concepts, and groups in the security layer. Do you have a concept of multi-tenancy and how you share the memory between the different users and groups?
Okay, so great question. The question is, you introduced in 1.1 the idea of users and groups. Do you also include kind of quota management and like that associated field of features which are related to users and groups? Currently, in the latest version of Alluxio, we don't provide quota management, but this is definitely a very important feature, I would say, in many production environments. And we're definitely open to contributions from the community, as well as if enough of the community votes for this type of feature, we look to allocate time to implement this in the open source project.
Okay, next, go ahead.
Hi, this is Fuyao from Google. So I'm very interested to see that you mentioned Fuse integration with Alluxio. So my question would be, if we already have a proper implementation of the Fuse layer, does that mean we could use the native file system interface as the middle layer instead of using the program API layer of Alluxio? And if we can do that, that means that we are not necessary to use the unified namespace. Like we can instead of using the local interface.
So I'll try to answer this to the best of my ability. I think the answer to the first part of your question is yes. We should just be able to put through the Fuse interface, just to use normal local file system namespace to interact with Alluxio. The second part of the question, I'm not sure I quite follow. Would you be able to?
So in your demo, you basically showed us how you could mount different component, different
Storage systems,
to Alluxio. But the benefits of using the unified namespace is that we would have the unified access URL, we call that, to your program, right? But assume that if you also mount the Alluxio to your local file system, the Fuse, then I could also just use my local file path.
Yeah.
And does that achieve basically the same thing?
So I think those two are actually orthogonal, right? One is what is the namespace that your application uses to interact with the data. And through Fuse, you can use the local file system. Through the other APIs that we provide, be the native or the Hadoop compatible, it would be the Alluxio namespace. And whichever of the two namespaces you're using, what sits underneath that is independent. It depends on what you mount it onto what path, right? So maybe you're using Fuse to talk to /Alluxio/foo that's being backed by S3, in fact, and /Alluxio/bar that's being backed by GCS. Does that answer your question?
Yeah, sounds good. So just one final question. Do we expect a performance difference, like from using two different methods? Do we use it, if we use Fuse, do we expect performance issues other than?
Okay, so I think it would be fair to say that there's going to be a performance difference because the software stack being exercised is different. I'm not sure whether Fuse should be expected to be much slower. Yeah, I think if you're interested in this, you should definitely get in touch with us, and we would be very happy to work with you on profiling and possibly improving the performance in case there are any issues.
Okay, let's go back here.
So this is Dong from my part. So first of all, thank you for the excellent presentation. So I have two questions. The first question, to use Alluxio with HDFS, my understanding is that you have to load the entire block from HDFS to Alluxio. Is there a reason why you designed it like that?
So I don't think you have to load the entire block. The concept of a block in Alluxio is independent of the concept of a block in HDFS, first of all. So you can actually choose different size of blocks for Alluxio in case you only want to read part of the file. And the other part of the answer is Alluxio actually allows you to specify different types of what we call a read type. You can say, when I'm reading this file, I want to store it in Alluxio after it is read. Or I want to store it in Alluxio and move it to the highest tier of the tiered storage. But you can also specify that you want to read this file and you don't want to store it in Alluxio because you know that there's not going to be any temporal locality. Perhaps the application knows that this is a one-time read and it doesn't want to spend the storage space available in Alluxio that way.
Okay, the reason why I mentioned that is because there's a paper from Baidu or article. It mentioned that there are several problems they encountered while implementing Alluxio into their productions. So one problem is that they found out they have to read the entire blocks of HDFS in production.
I see. Okay, so I think this might be referring to the partial reads. That's something.
Yeah. No. You can. Yeah.
This is actually something that was addressed in the latest version that Jim talked about. Previously, it was the case that in order for a block to be materialized in Alluxio, you actually had to read through all of it. However, with the latest version, there is now a configuration option that lets you select or whether you would also want to store partially read blocks into Alluxio or not. This incurs an overhead because possibly a very small read might result in, it's one-time overhead in reading additional information in order to have it available in Alluxio. But this one-time overhead can be amortized over the subsequent reads. But yeah.
Thank you. So the second question is that you mentioned all your metadata is in the master and you use worker, server, state, and node. Can you talk about the failover and the load balancing schema in Alluxio?
So for master failover, we support fault tolerance through Zookeeper. So there is a primary and standbys, and all the metadata operations are being journaled before they're actually reflected in the namespace. And if you recall Gene's talk where he talked about metadata improvements, there was some recent work we've done on greatly improving the scalability of the journaling to remote HDFS journal, which is exactly the use case for a master fault tolerance or failover. For the worker data, the replication or fault tolerance story that Alluxio currently has is that a block can possibly be stored on multiple workers. This happens when an application that has a local worker wishes to read data stored on a different worker. In the course of this operation, the block will end up being replicated for the sake of future rereads. But in case a worker fails, the data that was stored in its volatile storage, that would be the memory tier, goes away. And it's up to the application to decide whether that's okay. And in that case, Alluxio uses the concept of lineage, offers the concept of lineage to allow recomputation of the data, as well as provides modes for actually persisting the data either asynchronously or synchronously. And there's different trade-offs there. The lineage has overhead on the applications to be more sophisticated. The asynchronous persistence provides better durability, and it's easier for an application to leverage. And the synchronous persistence is clearly the best durability guarantee that you can have with no application overhead. However, you lose the performance benefits.
What about load management?
Yeah.
So maybe quickly, we just informed that we have coffee and stuff for maybe we can do the question. Maybe we'll do one more quick question, and then we take them in the lobby to allow networking more.
Sounds good.
Okay, so maybe, one more question here.
No, if he wants to finish off his question.
Oh, there was still a third question, I thought too.
So
He was asking about load balancing.
Okay,
Yeah.
you finish it then, okay?
So I just want to know, like, is there any load balancing between workers? So that's my question.
Yes and no. So you can do load balancing through application layer, and for the hot data, we have transparent load balancing, but we do not do active load balancing.